Hi, I'm Tomer Nahumi from DELL EMC XtremIO, and today I'm going to show you a demonstration of integrating between Hyper-V 2016 and DELL EMC XtremIO X2. As you can see, I have two Hyper-V 2016 servers managed by System Center Virtual Machine Manager and connected to a dedicated XtremIO X2 single brick. In this demo, I created 4 LANs which are connected to shared disk on both Hyper-V servers. Now let's take a look at DELL EMC ESI 5.1 plugin. ESI is designed for Microsoft application administrators who manage storage and application provisioning and monitor storage health. This software enables administrators to view, provision, and manage Microsoft Windows, MS SQL, and Hyper-V hosts. Connecting XtremIO X2 to ESI allows us viewing and managing all XtremIO objects such as volumes, capacities, storage controllers, initiator groups, and more directly from ESI plugin. Attaching a Microsoft cluster to ESI plugin allows us to view and manage all cluster objects directly from ESI, including cluster shared disks, host, mapping, and connections between the cluster volumes and the LANs in the storage array. A powerful ability of the ESI plugin is the ability to assign a LAN directly from the storage array to the Hyper-V cluster. Here, we select the X2 storage array and the storage pool, which in our case spans across all of the storage system capacity. Then, we specify the volume count and the naming pattern and then the volume size. Next, we select the initiators and the cluster disk options. On this tab, we select the partition properties and set the block size to 16K, which is our best practice for Windows servers. Now we are ready to go. This process creates a LAN on the XtremIO X2 storage array, maps them to the Hyper-V servers in the cluster, performs rescan, creates file system, and then adds the volume to the cluster as available storage, all using one simple operation. Looking at our storage array, we can see that the 4 new LANs have been created and mapped to the Hyper-V host in the cluster. Connecting the Hyper-V host as hypervisors to ESI allows us to get information about all the disks that are connected to the servers, the initiators, and all the virtual machines which reside on top of them and their virtual disks. Another interesting ability is adding a pass-through or VHDX disk directly from the XtremIO X2 brick to a specific virtual machine. This task creates a LAN in the storage array and then maps it to the relevant Hyper-V cluster and attaches it to the selected virtual machine as a pass-through disk. Looking at our storage array, we can see that the new LAN has been created and mapped to the Hyper-V host clusters. The next thing I want to show you is how ODX operations are handled by XtremIO X2. The ODX feature allows large segments of data and even entire virtual machines to be moved or copied at speeds significantly faster than legacy methods by offloading the file copy or transfer operation to the storage array. XtremIO has implemented ODX support using the storage array's native XVC functionality. When an ODX token for a given file is created, the array will create a read-only snapshot of the data segment to preserve the point-in-time copy of the data being copied, and then performs an internal copy operation to duplicate the data. Here, I have a Windows 2016 virtual machine which reside on XtremIO X2 LAN that I created earlier. Now, I'm going to clone this machine 20 times using a GUI PowerShell script I created in advance and monitor the performance during the operation. Here, I'll specify some basic parameters and then give it a go. We can see the outstanding bandwidth of 7 gigabits per second in copy rates when running on top of DELL EMC XtremIO. Looking at the volume list, we can see that the ODX tokens are being created during the cloning operation. Now, let's power on all the virtual machines at once and see how the array is handling it. Each virtual machine will start running I/O that simulates intensive SQL workload. Now that all the virtual machines are up and running, we can see that this workload generates 170k IOPS and 750 megabytes per second bandwidth for this intensive Hyper-V virtual machines workload, while the latency for all I/O operations remained less than 0.4 millisecond latency, yielding the excellent performance for our applications. This tab shows the CPU utilization of our storage controllers. We can see here the excellent synergy across our X2 cluster, when all of our active storage controllers share the load and effort, as the CPU utilization between all of them are virtually equal for the entire process. The last thing I want to show you is the efficiency of the XtremIO unmap operations. When a large file is deleted at the host or the guest level on a supporting file system, unmap commands will be invoked and sent to the array. The array will clear the unused data immediately, allowing maximum efficiency and utilization of the storage. Now, I will delete all the virtual machines that I created earlier and take a screenshot of the array capacity. As you can see, the X2 storage array removing the blocks which are no longer in use and freeing the logical and physical space. The dedupe ratio is reducing as well, since most of the data is a copy of the parent virtual machine. After completing the process, we can see that the logical space has shrunk from 2.5 terabytes to 600 gigabytes, while the physical space has shrunk from 234 gigabytes to 224, which highlights the extraordinary deduplication mechanism of the XtremIO X2 storage array. I hope you will find this demo useful, and thank you very much for watching.